I didn't grade your exam yet, but I will do that during spring break. So somewhere during spring break, you will be able to see your exam score. Let's keep doing with area in polar coordinate. Draw the polar graphs. And establish the integral formula. Which calculates the area of inside both curve. The first one is r equals 3 plus cosine of theta. And the second curve is r equals 3 minus cosine of theta. So in this problem, we have to figure out two graphs, and then we will have to figure out the area inside of those curves. As we have been doing to draw the polar graph, we graph y equals 3 plus cosine of theta, cosine of x, and y equals 3 minus cosine of x. So what we will think about is the original cosine graph. If we think about the original cosine graph, it looks like this. We will just think about one cycle. This is y equals cosine of x. And the other graph I want to graph is a minus cosine of x. Then it switches the y value, so it looks like this. This red graph is y equals 3 minus cosine, just a minus cosine of x. If you look at the graph, then let's just switch the order of expression. Y equals cosine of theta plus 3, and the other one is y equals minus cosine of theta plus 3. So when 3 are added, Doge means shift up 3 units. So to graph the given graph, we will just push upward 3 units. So x-axis will shift to x equals 3. So new x-axis will be x equals 3, y equals 3, and then new maximum will be 4, and new minimum is 2. Let's graph y equals cosine of x plus 3 first, then it starts at the maximum. And the graph will look like this. So this is y equals cosine of x plus 3. The other graph was flipped, this time flipped along y equals 3. So it looks like this. So red graph is y equals 3 minus cosine of x. And then the next task is translating that to the polar coordinate, polar graph. Could you please activate your camera, because just one person is activating the camera and I cannot see you at all. When we classify the type of the polar graph of this equation is Limassong. However, it doesn't have inner loop because everything is shifted up like this. So let's draw the black graph first. When angle value is 0, distance from the origin is 4. So 1, 2, 3, 4. And then when that is pi over 2, distance between the origin and that point is 3. When that becomes pi, the distance becomes 2. And when the angle is 3 pi over 2, the distance is 3. So it should pass minus 3. And then when that becomes 2 pi, it becomes 4 again. So the graph will roughly look like this. And we do the same reasoning. When x value equals the angle is 0, the distance is 2. When angle is pi over 2, the distance is 3. So the same point will be passed. And when the angle is pi, the distance is 4. 3, -4. And when angle is pi, 3 pi over 2, that passes 3 again. And when that is 2 pi, the distance is 2. So it passes here again. So the other graph looks like this. This red graph is r equals 3 minus cosine of theta. And that black graph is r equals cosine of theta plus 3. So what is asked to do is calculate the area of inside of both curves. So inside of both curves, the overlapping area is right here. So this is the part you have to calculate. So from here, what you can see is this side and right side are symmetric. If you look at the graph, this graph, black graph and red graphs are symmetric, right? And when we transfer that to the polar coordinate, those will be symmetric again. And so what you will do will be, we will calculate only this area because those are symmetric. And then we will double the area. Indeed, if you want to calculate both, and then you have to compart the inside of the curves into two different regions from negative pi over 2 to pi over 2 and pi over 3 to 3 pi over 2. For this right side, we have to use the equation r equals 3 minus cosine of theta. And this side curve, left side area, we have to use the different equation. So that is inconvenient. So after some observation, we will do only one calculation and double it. So area is 2 times integration minus pi over 2 to pi over 2, 1 over 2 r squared d theta. In this region, red graph is involved. So this is 2 times minus pi over 2 to pi over 2, 1 over 2. This red graph, this is this part. So the equation is 3 minus cosine of theta squared d theta. So that becomes integration minus pi over 2 to pi over 2, 3 minus cosine of theta squared d theta. And then this becomes a usual calculation, which you can finish. So today's lesson, I will explain the setup process, which is extremely important, and then remaining part will be calculated by you. Let's move on to the next one. Next one will be about cardioid and circle related calculation. Draw the polar graphs and establish the integral formula which calculates the area inside the first curve and outside the second curve. R equals 4 minus 4 sine of theta, and the other one is the R equals 4. So in this question, we have to draw the polar graph, and then we have to establish the integral formula, but they are not asking us to calculate things. The region is the inside of the first curve and the outside of the second curve. So we have to think about this. So we will write the equation y equals 4 minus 4 sine of theta. We have to figure out how the graph look like. So if we think about y equals 4 sine of theta, then that is a typical sine graph, which has a vertical stretch. So maximum becomes 4 and minimum becomes minus 4. And the sine is 0. Start at 0, so it looks like this. So this is the one cycle of y equals 4 sine of theta, but what is used here is minus 4 sine of theta. So we have to do vertical reflection. So we will just flip it, then it looks like this. Now we are adding 4 here. So that is vertical. Shift up 4 units. So in the graph, y equals 4 minus 4 sine of x. The vertical shift is up 4 unit, so the maximum will be 4 plus 4, and the minimum will be minus 4 plus 4. That's because before we add the add 4, maximum of this graph is 4 and minimum of this graph is -4. And so we added 4 to the maximum and minimum. And so that becomes 8 and 0. So so it looks like this. Then what we have to do is we have to transfer that to the polar graph. So those two numbers are the same, so that'll become a cardioid. So when angle is 0, the distance is 4. So here, and when angle is pi over 2, the distance becomes 0. And when the angle is pi, the distance is 4, so it hits -4. And when the angle is 3 pi over 2, that distance is 8. So here, so it hit -8. And then when angle is 2 pi, the distance becomes 4 again. So this is a cardioid. How does it look like? It looks like so the equation for this is r equals 4 minus 4 sine of theta. And the other graph is the graph of a circle. This is r equals 4. This is circle with radius 4 and center at the origin. In the problem, What they are saying is inside of the first curve is a heart-shaped curve, and outside of the second curve, so that is r equals 4. So the area we want to calculate is right here. And then when we just look at the graph, definitely those two are meeting at here. We are thinking about the polar coordinate. So the angle is important. So for these intersection points, corresponding angles are pi and 2 pi. And the other aspect we can observe from here is which graph is farther, because we have to subtract from the larger one to the smaller one. So when we draw the ray, this black graph is larger, farther. And this blue graph, which is a circle, is closer. That means we have to subtract from the farther one to the closer one. But if you want to calculate the intersection points, you can still do it algebraically. That is 4 minus 4 sine of theta equals 4, because this is an equation of a circle. The left side is the equation of a cardioid, which is given like this. So we made them equal. And then what happens is this 4 and this 4 will cancel each other, and minus 4 sine of theta equals 0. So sine of theta equals 0. We just divide by minus 4 on both sides. And then theta is 0, pi, and 2 pi, right? Because the graph of the sine look like this. This is 0, pi, 2 pi. So by looking at the graph, it is obvious that we have to integrate from pi to 2 pi. So the formula we have to establish will be pi to 2 pi, 1 over 2 r squared, but larger circle, farther one minus the closer one. So farther one was a heart-shaped curve. So 4 minus 4 sine of theta squared minus radius squared. So 4 squared d theta. Any question?
Professor,
Yeah.
for when you wrote the area formula, is there supposed to be a 2 outside of the integral or not on this one?
No. What I have been doing is this is the The area formula is from certain angle to angle and 1/2 r squared d theta. That is the area curve. But what we have been using is, for example, in this case, what we were doing is we argued that this part and this part are the same, right? But so for our convenience, we will just do half of them. So we have to double it to get the entire area.
So the 2 was only for when it was symmetric, because you have to double it.
That's correct. Exactly. Yeah, but you remember it pretty clearly. So any other question? Draw the polar graphs. And establish the integral formula. Which calculate, again, it is enough to calculate the integral formula. This time, officially, this graph must be classified as Limaison, but it doesn't have inner loop, but it's rather look like cardioid. As we did, we will follow the same step, and then we will just graph this and graph the other one. So let's graph this. To do that, we just figure out y equals 3 sine of x first, then it becomes 1, 2, 3. It bounded by 3 and minus 3. So in this case, we have to shift up only 4 units. So maximum of 4 plus 3 sine of x will be 3 plus 4, right? 3 plus 4, which is 7. And minimum of 4 plus 3 sine of x is a minimum was minus 3. And we are adding 4, so that is 1, right? And we have another graph. Y equals 4 plus 3 cosine of x. To do that, we start with cosine. Y equals 3 cosine of x Then the graph will be general pattern of cosine. So we will start at the maximum 3. So maximum of 4 plus 3 cosine of x is also 7. 3 plus 4 equals 7. And the minimum of 4 plus 3 cosine of x is minus 3 plus 4, which is 1. So what we want to do is after we drew this graph, we will transfer the two graphs in one plane. Before we do that, we will calculate the intersection point. So we will make these two equations the same because radius must be the same. So we will set up the equation intersection point. So 4 plus 3 sine of theta equals 4 plus 3 cosine of theta. So we subtract 4 on both sides, and then that becomes 3 sine of theta equals 3 cosine of theta. And then we divide by 3 on both sides. Then that becomes sine theta equals cosine theta. So we divide by cosine of theta on both sides. Then on the left side, we have sine over cosine, which is tangent of theta equals 1. So that is pi over 4 or 3 pi 5 pi over 4, right? So that becomes either in the first quadrant or third quadrant with the reference angle pi over 4. This is pi, and so when we add them up, we have 5 pi over 4. So theta equals pi over 4 and 5 pi over 4. That is the intersection point. So let's shape the graph in the same plane. Are you talking about this page? Let me know when you're ready. This? Are you ready? So we have to start with this. When x value equal the angle is 0, it's started. No, that it doesn't start at 0. When angle is 0, I think one page. Yeah, we had to shift it. I'm running out of time. So let me do this. I will finish the shifting up graph and then I will finish the problem next time. So we have to graph y equals 4 plus sine of y equals 4 plus 3 sine of x. Then this sine graph will shift up 4 unit, and this maximum will be 7, and axis will shift up 4 unit, and so it becomes 4. So maximum is 7. And so the minimum is 1. So we will bound like this. So it starts in the middle. So it starts in the middle, and then it'll follow the general shape of the sine graph. And this is cosine, and then we have to shift up 4. And so the graph look like this. This is y equals 4 plus cosine of x. And what we calculated was this intersection point. This intersection point is pi over 4. And this intersection point is 5 pi over 4. I think so what will happen will be, even though it looks the equation itself should be classified as a the Limassol actual graph will look like a heart-shaped graph when that happens when the digit numbers are the same. And then this is this will look like a vertical cardioid, and this cosine graph will look like a horizontal cardioid. And so we will deal with a two heart shape, which are looking like this, and the other one look like this. So we have to analyze the graph. I think it'll be better to go slower tomorrow, starting from here. So I will end the class here. And if something was not clear, then you can remain and ask me question. Otherwise, you can leave.